Section 4, Video 2. Composite figures dealing with volume. So in this particular shape, we have the base of this building, which is a rectangular prism. We're going to add that to the volume of a triangular prism, and we will get our total volume. So we'll need each formula. So the first formula, if you remember, for a rectangular prism is length times width times height. So this volume will be length of 8, width of 5, and height of 6, which gives us a volume of 240 centimeters cubed. The triangular prism has a formula of area of the base times the height. Well, the base is a triangle. Okay, so remember we said that the bases of a prism are the congruent and parallel polygons. So a triangle is the shape that holds true throughout this prism. So we use the formula for a triangle, which is 1/2 base times height, and then we're going to take that times the height of the, or how long it is in this case, of the prism. So 1/2 base, which is right here. I'll take this off here and draw it with you. This is the base of the triangle, which is the same as this base length, so we know that is 8. The height is right here, and that's given right there outside the shape, telling you that this is 4. So that would be the triangle. Then we take it times the height of the shape, which is tipped on its side, but that would be considered, the prism's height would be that length, which is the same as this length, so 5. That calculation comes out to be 80 centimeters cubed. The composite shape, though, adds these together. We get 320 centimeters cubed per volume. Now we have another one, quite interesting shape. We have a cone. We have a cylinder in the middle and half of a sphere. And that's the 3 shapes we're going to put together. The formulas for each: 1/3 pi RH, pi r squared h for the cylinder, and it is 4/3 pi r cubed for the sphere, but we want half of it. And we're going to add these together. So the first one is 1/3 3.14 for pi times your radius. This whole thing is 6, which tells us that the radius is going to be 3 in every shape, times the height, which they tell us here for the cone is 5. Add that to the cylinder, which is pi, so 3.14 times your radius squared. Again, we said it's 3 times the height. Well, that height is from here to here. They don't tell us what that is. They tell us the whole length is 16. They tell us from here to here is 5. From here to here will be the same as the radius because it's a sphere. So that will be 3. So if we take 16 minus 5 minus 3, we will have our height, and that is going to be 8. So that one we had to think a little bit for. Plus 1/2 of a sphere, which is 4/3 pi again, times radius cubed, because it's a sphere. Calculate those together and we get 47.1, so 47.1 plus 226.08 plus 56.52 for that volume of half sphere. Add those all together and we get 329.7 centimeters cubed. All right, next one. Now those are all areas by addition. Now we have to find the volume of the cone if the cylinder is removed. So now it's going to be a cone, pardon me, that's just ugly, a cone, there you go, minus the cylinder. So the cone is, by formula now, 1/3, base is a circle, so pi r squared h. The cylinder is pi r squared h. So if we do the cone, we've got 1/3 times 3.14 times r. Now this is the cone, so the radius they give us is 9 squared times height of the cone again. So here's the cone, so 40. That calculation should give us 3,391.2 minus, so here we have 3.14 times r squared. Now this is the radius of the cylinder, so that's 3 squared times the height of the cylinder again right there, so that's 21. Nice drawing for us. That calculation should give us 593.46. Subtract the 2 and we get 2,797.74 centimeters cubed.